So, in this lecture, we are going to discuss in detail about the screw axis. In the last lecture, I had just briefly introduced the screw axis when we are developing some space groups. And towards the end of the lecture, what I had done was I had added a screw axis, two-fold screw axis to a primitive monoclinic lattice. And this is the space group where the symbol for the screw axis. So, all the two folds, typically there have been pure two-fold rotation symmetries. In this, all the two-fold rotation symmetries have been replaced by the screw axis. In this lecture, we will discuss the meaning of this symbol 2 sub 1, and we will find that there are other screw axes like 3-fold, 4-fold, etc. They will have different symbols. So, let us take first, for a purpose of comparison, let me just take a pure two-fold rotational axis. So, a pure two-fold rotational axis is, let us say, this black line that you see. Now, suppose I put a motif here, a 180-degree rotation. We will take this motif here, and if this is T, which is a lattice translation, then both of these motifs will get translated along the screw axis in this manner, and so on. We can keep extending it to infinity. So, this is simply a pure two-fold rotation symmetry. Now, let us consider a two-fold screw axis, 2 sub 1. So, as I said, there is going to be a rotation of a two-fold, which is a rotation of 180 degrees, followed by a translation, and let me call the translation as tau. And how much should be this translation? Well, in this case, the translation would be half of the lattice translation along the screw axis. So, this T is lattice translation along the screw axis. So, now I put a motif here. Let me label this as motif number 1. I rotate it again through 180 degrees. So, it should actually come here, and then I translate it up by half the lattice translation, half of the vector T, and this motif comes out here. Now, this motif I had drawn, but this must be removed because this motif is not kept here. So, rotate 180 degrees, follow it up with half the lattice translation. Therefore, one thing is that any screw axis is a two-step operation, just like the glide plane. In a glide plane, we have a reflection followed by translation parallel to the glide. In this case, I have a rotation followed by a translation parallel to the axis, screw axis. So, this motif number 1 comes to motif number 2. Again, another 180 degree rotation, and you go up again half of the T vector, and we form motif number 3. And then again 180 degrees, go up, this becomes motif number 4. Another 180 degrees, and we reach motif number 5. So, this is the kind of pattern we will form along the screw axis for this particular case, which is a two-fold screw axis given by the symbol 2 sub 1. Now, if I look at specifically at motif number 1 and 3, how are they related? Well, it is easy to see that they are related through simply a lattice translation. Similarly, you will notice that 3 and 5 are also related through lattice translation, 2 and 4 are also related to lattice translation. So, this pattern is somewhat different, 2 sub 1 pattern is somewhat different from the pattern obtained on a pure two-fold rotational symmetry. Now, let us go to some higher screw axis like a three-fold rotational symmetry. First, let me draw the pattern for a pure three-fold. So, I have a motif here, we rotate through 120 degrees about the axis, this motif comes out here, another 120 degrees, the motif comes here, another 120 degrees, we come back where we started from. Now, let us assume that this is a lattice translation. So, all the three motifs will get translated along the screw axis by this lattice translation T, and we get this pattern as we expect for a pure three-fold rotational symmetry. Now, let us come to some, just like we had a symbol for two-fold screw axis 2 sub 1, let me put this symbol as 3 sub 1. But what we would find is now I have more than one screw axis for the three-fold screw axis. So, I have 3 sub 1, I can also have 3 sub 2. Now, what does this mean? The difference is in the magnitude of the screw axis translation. So, in this case the translation tau is 1/3 of the T vector. In this case the lattice translation is 2/3 of the lattice translation. You can see from the symbol now how I can get the translation along the screw axis, where again T, I should write this here, is a lattice translation along the screw axis. Now, I put a motif here, rotate through 120 degrees, I come out here and then I go up by 1/3 the lattice translation and I reach to this position. So, this is motif number 1, I reach to motif number 2, another 120 degree rotation, I go up to motif number 3. Another 120 degree rotation, I go up to motif number 4. Another 120 degree rotation, I go up to motif number 5. Another 120 degree rotation, I move to motif number 6. Another 120 degree rotation and I move to motif number 7. So, this is the kind of pattern I would be getting for a three-fold screw axis with a translation vector as 1/3 T bar. Now, if I look at it carefully, this is 1/3 T, this is also 1/3 T, this is also 1/3 T. So, the total translation from 1 to 4 becomes the lattice translation T. So, in fact, one can see many of them. So, for example, I have here going from 1 to 4 is a lattice translation, going from 4 to 7 is a lattice translation, going from, if you look at it, going from 2, so I go 1/3, 1/3, 1/3, 2 to 5 is a lattice translation, and so on. You will find obviously many cases with lattice translation. This becomes the pattern for this particular screw axis 3 sub 1. Now consider the second screw axis 3 sub 2. Here now the screw translation is 2/3 of the T vector. So, starting again, let us start with motif number 1. We rotate through 120 degrees, but now we, instead of moving 1/3 T, we move 2/3 T. So, this is 1/3 T, this is another 1/3 T. Hence, to move from this point out here, we move up to this position. So, this is 2/3 the T vector. So, I move to position 2. Another 120 degrees, then I go up 1, 2, so 2/3 T again, this is 3, another 120 degree rotation, I go up 2/3 T, I move to this position, let me call this as motif number 4. Now, what else can I do in this? Well, so far I am not seeing any motifs which are related to each other through lattice translation. But then we can, anyway lattice translation is always operating. So, we can now introduce the lattice translation in this. So, let us say going from 1 and the lattice translation would be 1/3, 1/3 and another 1/3 to reach this point. So, I go up 1/3, another 1/3, another 1/3, I go from 1 to 5 and this is the lattice translation. So, 3 basically 3 times 1/3 gives me the lattice translation. You can also see that you can go from 5 to 4 now through another lattice translation. Then if I look at 2, so I go 1, 2, 3, this becomes a lattice translation. So, this becomes 6. If I look at 3, so I go 1, 2, 3, I move here and this is motif number 7. Now, we have the complete pattern here for the 3 sub 2 screw axis. Now, here let us take a look at how is it different if I compare the 3 sub 1 and 3 sub 2 screw axis. So, let us consider the 3 sub 1 screw axis. The 3 sub 1 screw axis, you go 120 degrees, go up by 1/3 times the lattice vector, another 120 degrees, you go up 1/3 the lattice translation vector. So, as you are rotating, you are moving up the axis, the motifs are moving up the axis and the motifs can be joined by a helical path. If I look at 3 sub 2, so let me look at it in the reverse manner. How do I go from 4 to 6? Going from 4 to 6, how to do this is rotate in the same way 120 degrees and translate by minus 1/3 times t. 6 to 3, I rotate 120 degrees, I come here and then I go again by minus 1/3 t. And you will notice that you can keep doing this and you will keep going down the screw axis. So, in one case, in 3 sub 1, when you are giving that same rotation, you are going up the screw axis. In this case, you are going down the screw axis, or you can say that the two screw axes, their helical paths are opposite to each other. One way to look at it is that this one we could call it as a right-handed screw. and this one could be called as a left-handed screw. So, now you have two screw axes for the three-fold case. Now, consider a screw axis with four-fold rotation, 90-degree rotation. Again, I will first draw the pure four-fold. Motif, you rotate by 90 degrees, another 90 degrees, another 90 degrees, and then translate through lattice translation. So, this is my pattern for the four-fold rotation symmetry, where T is the lattice translation. Now, I have three different screw axes in this case. This one I will call it as 4 sub 1. This one I am going to call it as 4 sub 2, and here this one I will call it as 4 sub 3. And I think you would be able to guess what are the translations involved in the operation of these three screw axes. In this case, tau would be 1 upon 4 times the T vector. Here tau would be 2 by 4 times the T vector. In fact, 2 by 4 can be simply written as half of the T vector. In 4 sub 3 case, tau would be 3 upon 4 times the T vector. Let us start with 4 sub 1. So, I will start with motif number 1, rotate 90 degrees and go up to motif number 2, translated by 1/4 times the T vector, and another 90 degrees it will take me here, which is 3, another 90 degrees it brings me here 4, another 90 degrees comes here 5, 90 degrees comes here 6, another 90 degrees comes here to motif number 7. And this actually forms the complete pattern for those 4 sub 1 screw axis, and you can identify the lattice translations as well. For example, going from motif number 3 to 7, if I have to go from 3 to 7, so 3 is here, so 1/4, another 1/4, another 1/4, another 1/4, so 4 times 1/4 is a complete lattice translation. So, 3 to 7 is a lattice translation. If you look at 2 and 6, 1/4, 1/4, 1/4, 1/4, so 2 to 6 is also a lattice translation. Similarly, you can say 1, not 1, you can look at, oh, we have done 3 to 7, we looked at 2 to 6 and 1 to 5 is also a lattice translation. So, this is the 4 sub 1 screw axis. Now, before I go to 4 sub 2, I will look at the screw axis 4 sub 3. Here my lattice translation is 3/4 of the lattice. My screw translation is 3/4 of the lattice translation. So, we will begin as usual with motif number 1, 90 degrees, and now I have to move 2/3. So, we rotate 1 through 90 degrees and then go 1, 2, 3. This will give me 3/4. Then another 90 degrees and I go 1, 2, 3. So, this will give me 3/4 again, and this motif will come out here. So, that becomes motif number 3. Now, let us put also lattice translations on this. So, the lattice translation, for example, if I go from 3, I can also, lattice translation will operate in both directions, so it will operate in the downward direction as well. So, let us take motif number 3 and then move through a lattice translation, which means 1, 2, 3, 4, it will come out here. So, this becomes motif number 4. Now, if I look at motif number 1, move through lattice translation. So, 1, 2, 3, 4. So, this becomes motif number 5. So, I have 3 to 4 lattice translation, 1 to 5 is a lattice translation. Next I can have a look at, so in this manner. Now, remember we had seen in this case 3 sub 1 and 3 sub 2. What we had figured out was that you can have the screw translation in the opposite direction as well. So, same thing we apply here. So, rotate through. So, after all, just for example, let me show you this. Going from, how do I go from 5 to 2? To go from 5 to 2, I must rotate through 90 degrees and then go minus 1 upon 4 t. So, this is rotate through pi by 2, follow it up with a screw axis translation of minus 1 upon 4 times the t vector. So, you can see here that this operation is also valid for the screw axis, whose positive translation is 3 upon 4 times the t vector. So, which means that I can take motif number 3, rotate through 90 degrees, I come here and then move down by minus 1 upon 4 times t to bring the motif at this position. Let me call this as motif number 6, and then apply a lattice translation to motif number 6. So, 1, 2, 3 and 4, I come at this position, and now this completes the pattern for the 4 sub 3 screw axis. So, as you can see, it is very similar to the previous case of 3 sub 1 and 3 sub 2, where 3 sub 1, as you are rotating, you are going up the axis, and in 3 sub 2, as you are rotating, you move in the opposite direction by the same amount of 1 by 3. So, here also it is the same thing, that in 4 sub 1, we are moving up, in 4 sub 2, we are moving down. It is like, again, 1 is kind of a right handed kind of a thing. So, this we can call it as right handed, and this one can call it as left handed, but this is not right handed and left handed in the sense of chirality. So, there is no change in the handedness of anything. So, that is why I am calling it, this is a right handed screw and this is a left handed screw. Now, coming to the third screw axis, 4 sub 2. So, 4 sub 2, motif number 1, we rotate through 90 degrees and then move up by half the t vector. So, my half the t vector is out here. So, this is 2, rotate again another 90 degrees and move half the t vector, I come out here, and this is motif number 3. Now, I can also operate lattice translations on these. So, for example, 3 through a lattice translation of t means all the way out here. So, 3 goes to 4 through a lattice translation. So, this is a lattice translation. If I look at motif number 1, we go up through a lattice translation to motif number 5. Now, take motif number 5, rotate, or rather take motif number, let us see, what have I missed? No, Take motive number 3, rotate through 90 degrees, go down minus 1 upon 4 t. So, from here we move down to motive number 6. The interesting thing you will see regarding this pattern is that there is a clearly a pure two-fold rotational symmetry also existing. So, what this basically means is that the subset of 4 sub 2 is pure two-fold rotation. Now, just before I conclude this lecture, I will put symbols that I have not yet put. So, starting from 2 sub 1. So, with 2 sub 1, so this is the symbol for 2 sub 1 that we have already seen. Symbol for 3 sub 1 is draw the triangle first and draw fins in this manner. Three sub 2, compare it with 3 sub 1, we draw the fins in a reverse manner, and that would distinguish the 3 sub 2's graphical symbol. Now, let us look at 4 sub 1. And 4 sub 3, we will simply reverse it. Now, coming to 4 sub 2, so you can see the symbol for 4 sub 2 is such that you can see that there is a subset, the symbol itself has a two-fold rotational symmetry. So, with this I conclude the lecture on the screw axis symmetry. Thank you.